Hello everyone, in this video we are going to discuss about how TLS or SSL works in detail. As part of this video, we are going to discuss what is TLS, what is the difference between TLS and SSL, what is the difference between TLS and SSH, and what is the difference between TLS and HTTPS, and we are going to discuss about the TLS certificate details, and finally we are going to see how to generate TLS certificates. TLS means transport layer security. So TLS encrypts the communication between the client and server applications. For example, in case of web applications, it encrypts the communication between the client application, for example, the web browser, and the server application, for example, a web application hosted in some server. So how TLS encrypts the communication between client and server applications? For this, TLS uses the combination of the asymmetric encryption and symmetric encryption. So it uses the asymmetric encryption to establish the symmetric channel between client and server applications. Before explaining this flow, let us try to understand the asymmetric and symmetric encryptions. In the symmetric encryption, we have an input data. The encryption process encrypts this data, and if we want that data back, we'll have a decryption process which decrypts the encrypted data. In case of symmetric encryption, we'll use the same key for both encryption process as well as decryption process. And in case of asymmetric encryption, the input data will be encrypted using one key, for example public key, and the encrypted data will be decrypted using another key, for example private key. So as part of TLS, it uses the combination of asymmetric and symmetric encryptions. It uses the asymmetric encryption to establish the symmetric channel. That means to generate a shared session key between client and server applications. So once the shared session key is established, then the client and server will use the symmetric encryption to encrypt the traffic between the client and server applications. So let us see how it uses the asymmetric encryption to establish the symmetric channel. In the first step, the client initiates the connection to the server application. So while initiating the connection, it provides what is the version of TLS that client uses, and what is the key exchange algorithm is being used by client, and what are the cipher suits being used by client. So this key exchange algorithm will be used to exchange the keys between the client and server applications. So we have different key exchange algorithms like RSA, Diffie-Hellman, and so on. Here the cipher suits are the combination of different algorithms which uses the key exchange algorithm and other encryption algorithms to have the secure communication between the client and server applications. And then the server will respond with the TLS certificate to the client. So in addition to the TLS certificate, it also provides the supported TLS version, the key exchange algorithms, and the cipher suits and so on, which are supported by the server applications. Then the client and server will agree upon the common key exchange algorithms, cipher suits and so on for this encryption process. The client will verify the TLS certificate. That means it will verify the public key of the server application. In addition to the public key, the client also verifies other details like the certifying authority which provides that certificate to that owner and so on. Once it verifies the details, it successfully authenticates the identity of the server which provides the TLS certificate to the client. Once the TLS certificate is verified, the client and server will participate in generating the shared session key for the symmetric encryption. So for generating the shared session key, they use the combination of key exchange algorithms, cipher suits and so on, which are common between the client and server supported algorithms. Once the shared session key is obtained, which means a symmetric channel is established between the client and server. So once the symmetric channel is established, the traffic between the client application and the server application will be encrypted using the shared session key, which means the symmetric encryption will happen between client and server applications. So this way, the traffic will be encrypted between client and servers, which provides the security and integrity for the data which is transferred between the client and server applications. So in this way, TLS uses asymmetric encryption during the handshake process between client and server application. So the goal of asymmetric encryption is to generate the shared session key between client and server to establish the symmetric channel. So once the shared session key is obtained, the traffic will be encrypted using the shared session key by means of symmetric encryption. Now we have discussed about TLS, which encrypts the data which is communicated between client and server applications. Now let us see what is the difference between TLS and SSL. SSL, which also means Secure Socket Layer, which does the same thing as TLS. It also encrypts the data which is communicated between client and server applications. But the difference is that TLS is the upgraded version of SSL and it is more secure and efficient when compared to SSL. So what is the difference between TLS and SSH? SSH, which also means the secure shell, which is used to connect the remote machines via encrypted communication channel. SSH also uses the similar encryption algorithms as TLS, but the applications of SSH are different when compared to TLS. SSH is mainly useful to connect to the remote devices or remote machines using encrypted channel. Generally, the administrators will connect to the remote machines using SSH. Whereas TLS is used by multiple server applications to provide the secure encryption channel for the users of the applications. One more difference is, in SSH, the server will provide the public key of the host to the client directly for authenticating the identity of the server in the client. Whereas in TLS, it provides the public key in terms of X509 certificates. So this certificate will contain the information about the public key as well as other details like the owner of the certificate, the domains which will be supported by the certificate, and the certification authority which provides these certificates, and so on. Then what is the difference between TLS and HTTPS? HTTP, which is also called as Hypertext Transfer Protocol, which will be used for communicating the data between web clients and web applications. So HTTPS means HTTP plus TLS. So if we use plain HTTP, the communication will be insecure so that the hackers can see the data traffic which communicates between web clients and web applications. So for encrypting this HTTP traffic, TLS is used in addition to HTTP. That means HTTPS uses TLS over HTTP for the encryption. Now let us understand what is present in a TLS certificate. Now let us take an example with a web application where we will try to access one web application from the web browser. Here I am using HTTPS protocol. So let us try to access this URL. So when we access the URL, we have got this web page from the server. Now here if we click on this, here we can see that the details about the TLS certificate which was sent by the server to the browser client. Here if we click on connection is secure, then it is showing the certificate is valid. Let us click on this. Here we can see the certificate details. Here we can see the information like who is the owner of this certificate. Here the certificate is given to the organization ICICI Bank Limited, which has common name www.icicibank.com. So the certificate is given to this organization and the certificate is issued by this certification authority. So here the certification authority is Entrust Certification Authority. We have various CAs like VeriSign, DigiCert, Entrust, and so on. When the certificates are issued by the certification authority, then the browsers will accept the certificate automatically. If the certificate is not verified by CA, when we access any web page, then it will ask whether to accept the certificate or not. Here the certificate is verified by CA, so it did not ask here. Here we can also see the validity period. That means this certificate is valid up to this date. Here we can see the fingerprints of the certificate as well as public key as well. So the web browser client will verify all these details to authenticate the identity of the server. In addition to the data about the certificates, we can also see other information like which algorithms are used, which protocol version is used for TLS. For that, let us click on here. So here let us select more tools and then select developer tools. So under this, if we click on security, this also provides the certificate details, and here we can see that the connection to this site is encrypted and authenticated using TLS 1.3. That means here we are using the TLS protocol with version 1.3. Here we can see a key exchange algorithm X25519, and this is the cipher which is used by the secure connection. So let us see what is this key exchange algorithm. So here we can see an elliptic curve Diffie-Hellman key exchange algorithm, which allows the client and server to jointly agree on shared secret using an insecure channel. Similarly, we can get the details about this cipher. So this cipher is an advanced encryption standard, which is an encryption algorithm that is used to encrypt the data. So that means in our example, the TLS encryption happens using TLS 1.3, elliptic curve, Diffie-Hellman key exchange algorithm, and this is the cipher. Now we have seen an example TLS certificate details. I also wanted to explain how to generate TLS certificates in this video, but it would be more appropriate to generate the TLS certificate and configure that with an example application. So I'll do that in the next video. So this is the example application I would like to set up in the next video. As part of that, we'll generate the TLS certificate and we'll configure TLS for the Nginx application with the generated certificate. So we'll see this in the next video. So in this video, we have seen how TLS works, and also we have seen the difference between the TLS and various protocols, and we have seen the basic details of an example TLS certificate. I hope this video helps. Thanks a lot for watching.